Okay, so for today's lesson, we're going to be looking at our basic parent functions. Many of these you've already been introduced to. Some of these might be new. We're going to be looking at all these different types of functions throughout the year. Our first type of function is probably the first function many of you guys were introduced to when you were in Algebra 1, and that's our linear equation. Now, our domain of this equation is written as negative infinity to positive infinity. Our range is negative infinity to positive infinity as well. Now, both of these can be expressed by using this expression. We could say the domain, x, and then we'd have a big cursive e. That's actually a letter epsilon. It's Greek, kind of like the letter pi that we see in geometry and when we're working with circles. And then we'd have a double-backed r. What that stands for is a real number. And I know many of you guys have already used this vocabulary in class. A real number is any number that does not have an I with it. So no negative square roots allowed in the linear function. Our next type of function is y is equal to x squared. So we saw this in Algebra 1. We spent a lot of time with it in Algebra 2. We're going to spend some more time with it this year. It's our quadratic function. Quadratic function reaches a minimum at x is at the origin. We have our domain from negative infinity to positive infinity, and we have our range from 0 to infinity. Now, I do want to just point out that this bracket is very, very important. When you see a bracket, you have to include it. When we're looking at the bracket means this. It means that 0 is in the value. Okay? It means that we have to include it. It does pass through 0. And you're going to see why we have to include it on our very next function. Our next function we have is exponential growth. Now, our exponential growth function does have this parentheses here on the range instead of with the bracket that we saw in the previous question. So what that's going to tell us is that we have what is called an asymptote. The asymptote, of course, is when the range is when y is equal to 0. And our key here is going to be this whole first part where we have a parentheses with a number. So we've got parentheses 0 means that we have an asymptote at 0. Now, the other important point that you want to make sure that you have is right here. We had the point 0, 1. It is a very, very important point that we're going to be using quite a bit on that function. Now, our next function is very, very similar to the exponential growth. This is actually given by the exponential decay. Our exponential decay still has the same domain, negative infinity to infinity. Whatever the value is, we can put it into our equation. Now, our range, you might notice that the range is the exact same thing. Again, we have a number with a parentheses here. And what that's going to tell us again is that we still have our asymptote at y equals 0. Now, this graph will also pass through the exact same point of 0, 1. Our next function that we have is our absolute value. This function we see occasionally, and it has the same domain. The range, though, if you might look back, is the same range as the quadratic. We still have our bracket here around 0. And like I said earlier, if it has the bracket, that means there is no asymptote. The function does pass through the origin, and so because it goes through the point 0, 0, we have to have this y value included in our range. Now, our next function is a function that we see occasionally. We're going to spend actually almost an entire unit on, which is called the rational function. Some people call it the reciprocal function. Our rational function can be written in two ways with the domain. So the first way we have it is negative infinity to positive infinity, and then this little comma. This little comma is like a but. But x cannot be 0. And so just like if you see a no smoking sign or a no parking sign, we've got our equal sign, but we've got a big slash through it to say no. Now, the other way, and the way that we wrote it down out of the book, was we said the domain was negative infinity to 0, then we had 0 to infinity. Now, the book also had a big letter U in between these two. The big letter U stands for the union. It means that these two sets are married and they have to go with each other no matter what. The range, you might notice the domain and the range are the exact same on this. So of course the range can be notated the exact same way. Now what we said earlier was that if we see these parentheses like this, what that's going to tell us is that of course we have asymptotes. So the first asymptote I'm going to have is on my domain, because the first one I got was from my domain. So I'm going to be looking at x is 0, because I know that x cannot be 0. Our next one says that y cannot be 0, and so that's going to tell me I'm going to have an asymptote at y is 0. So this function has two asymptotes, and typically the way we're going to sketch a rational function would be to start by drawing the asymptotes. It's always the easiest way to start it, and it's also why we have to be able to calculate it. We'll be looking at how to calculate these later. Now our next function is the logarithm function. The function is given by log base b of x. Now our graph, you might notice on our graph we're coming right up next to the x-axis and then it curves up. This graph will pass through a point that we should be able to recognize, which is 1, 0. Now at this point we should kind of recognize, we see that we have a parentheses with a number here. So again, just like with the rational function and with the exponential growth and decay function, that means there's an asymptote. Now I know this is in my domain, so that's going to tell me I have an asymptote at x is 0. So I'm going to go ahead and draw my asymptote right down the middle of x equals 0. Now the final question that's on our actual worksheet is the square root function. The square root function is given by the domain of 0 to infinity, and the range is the exact same thing, 0 to infinity. So we start at the origin and we kind of curve up slowly, and it's going to keep going in that general direction. Now both of these have a parenthesis, or have a bracket instead of a parentheses. So like we saw earlier with absolute, that means there is no asymptote on this equation. Now one thing I do want to add on here is that this goes for any function where n is even. That's been a test question in the past, and so in even root we're just going to look at even numbers. So we might have things like the 4th root of x, the 6th root of x, the 8th root of x. It doesn't matter as long as you know that all even roots follow this just general pattern of starting at the origin and curving up real nice and slow. Okay, so we have just a couple of functions left that I would like to have a little bit of exposure to. Our first type is a cubic function. A cubic function is given by side, it looks fairly similar to a quadrant. The left side will be curving down. So it has two distinct directions. It's going to pass through the origin. The function that we'll be taking a look at is f of x. We're going to look at it if it's odd. So if the function is an odd value, such as the cube root of x, the 5th root of x, the 7th root of x, yada yada yada, whatever. We've got our domain. This time the domain is different from the even power. The range is different from the even power because now we have the negatives to worry about. The right hand side is going to look a lot like a even-powered graph. However, now the left side is going to curl down kind of like a snake. And if you take a look, it almost looks like that x cubed graph on its side. Alright, we're almost done now. We have just a couple of functions left. Our first is one that we're going to spend a whole lot of time with in the third marking periods. It's called sine function. Okay, just like a street sign. Okay, it's pronounced sign. Make sure you're saying it. I don't want to hear anybody coming in and saying sin x. Now our domain is all numbers. It's a real number. Our range though is negative 1. You might see we still have the brackets here, so that means this function does not have an asymptote. This function is going to actually start at the origin. It's going to curl up and then curl back down on both sides. Now the thing about this equation, it goes up to +1, it goes down to -1. It's going to continue curling in both directions. It's going to continue to move up and down, kind of like the ocean. This is called the sine wave function. We're going to make sure we spend a lot of time with it a little bit later on. Our next function is our cosine function. Our cosine function is abbreviated as COS, and our domain and our range is the exact same. So there's only really one difference at this point in time for you guys to know between the sine and the cosine function, and that's where it starts. This function starts at 0, 0. The cosine function is at 1, 0. And it's going to curl down and continue in both directions. Now, you might notice that I'm not putting arrows on the ends of my graphs. So why would I not put arrows? Well, the reason is continue on in this direction. Okay? This function is going to continue to oscillate in both directions. That's the way it looks like. Our next two functions are we're going to start with the integer function. X. Now the domain of the integer function is all real numbers. However, you might notice that our range is only integers, just like the function looks like. Now integers are the basic counting numbers. We've got -2, -1, 0, 1, 2, 3, so on and so forth in both directions. Now, what this function is going to do is it's going to take any value that has a decimal and drop the decimal. We're probably not going to spend a lot of time with the domain and the range. Our last type of function is going to be exponential growth. Thing about the graph is it's kind of like the odd power group. It's going to curve up slowly, going to hit a specific point here, it goes through the point 0, drop a 1/2, and then it's going to curl up some more. Now the major difference is with this than the asymptote right here. The asymptote get higher than y is equal to 1. And so that's going to please feel free to let me know, and I'll see you guys next time. Bye.